Okay, this is about how to solve rational inequalities. And I'm using something called the LACING method to solve rational inequalities. And so I don't think this is in your textbook that we're using. So the biggest thing I want you to realize is what we're about to do is a really cool method, but it is not, do not confuse this with how to graph a rational function. This is not at all how you graph a rational function. That's a totally different situation. What we're doing is we're going to convert our rational expression, our rational function, into an equivalent polynomial, and then graph the polynomial, which is really pretty easy, and then use that to answer this inequality. So don't confuse that with how to graph a rational function. So here we go. These are the general steps. Number one, we're going to convert our rational function into an equivalent polynomial. Then we're going to sketch the polynomial, and we're going to be careful to put open circles on any of the zeros that we got from the denominator. And then we're going to interpret the graph to answer the inequality. I'll explain this a little more as we go through the example. The first one that we're given, and again you have a worksheet to follow along with me, is PR of x is equal to x plus 3 over x plus 2 times x plus 5. We will convert this to its equivalent. Here's its equivalent polynomial. Would be P equivalent would be x plus 3 times x plus 2 times x plus 5. Why can we do this? Well, because of this. What we're ultimately doing is saying, when is this greater than or equal to 0? So a number that's positive divided by a positive times a positive will be positive, just like a number that's positive, when you multiply it by a positive and positive will still be positive. So whether we're multiplying positive and negatives, or dividing positive and negatives, the sign remains the same. So if you have a negative divided by a negative, it makes it positive. If you have a negative times a negative, it makes it positive. Or if you had a positive and a negative, whether you're multiplying or dividing it, it will still be negative. So this does not change the sign when we do this. That's why it's okay to do that. Now, which zeros that we're going to get come from the denominator, -2 and -5. So here we're going to sketch our polynomial. So just like we just got through doing, let's find the zeros. X is -3. This is okay to be a solid circle because that came from the numerator. X is -2. That has to be open circle because it came from the denominator. X is -5. This also has to be open circle on my graph because it came from the denominator. Because domain is a really big deal. We can't change that. So let's see. The leading coefficient is positive up to the right. The degree is 3 odd. That means down to the left. Here's our little sketch. We've got a -5. Oops, that's a 3. A -5. We've got a -3 and a -2. Oh, I really crowded this up. Oops. And I'm about to do some illegal things. I already did. Let me fix that. This has to be an open circle. This can be a closed circle, and this is open. So let's sketch our guy down to the left at -5. Oh, multiplicity here. 1 cross, multiplicity 1 cross, multiplicity 1 cross. So let's see. At -5, it crosses. We're starting down left. So we're down here. We're going to cross. We're going to cross. We're going to cross. Okay, this is the sketch we get. So, where is this guy greater than or equal to 0? This is what we're trying to answer. Well, this has to be open, so we cannot include -5 no matter what. So the answer to this will be from -5 to -3. We can include the -3. And then union this with -2 to, this is my arrow, to infinity. So we can use our equivalent polynomial graph, as long as we mark the domain, to answer this rational inequality. So that's what we're going to be doing. That's the first example. Let's look at another one. Number 2 goes like this. I lost my little sheet. Okay, no, there it is. Number 2 is this. Q of R, QR of x is equal to 4x plus 3 times x minus 4 all over x plus 5 squared. Okay, this was this one. Let's find the equivalent polynomial form. Q equivalent would be 4x plus 3, x minus 4, x plus 5 squared. Let's find the zeros. X is negative 3/4. I'm allowed to have a closed circle there. X is 4. I'm allowed to have a closed circle there. X is negative 5. That came from the denominator. I must make that an open circle. The multiplicity of this 0 is 1. It will cross. The multiplicity of this is 1. It will cross. The multiplicity of this guy is 2. It will bounce. Okay, so let's make some room. I'm going to erase this other person, this other guy over here. It's not a person, but I feel close to math problems, so it's almost like a person. Okay, here is number 2. Right here. The equivalent version of this, we're going to graph this. Oh, in behavior, that's a big deal. Leading coefficient is positive up to the right. The degree of this is 1 plus 1 plus 2, which is 4, which is even, which means the left behavior will follow the right behavior up, up. So here we go, we're at negative 5, and I just did what I'm not supposed to do. Let me start again. At negative 5, it has to be a big open circle because not allowed to equal negative 5 because it started as a rational function. Oh, let's sketch it. I haven't even put the problem up there. What are we supposed to answer? We'll figure that in a second. And then negative 3/4 right here, negative 3/4, okay, and then 4 right here, 4 right there. Those can be closed circles. Okay, in behavior, up, left. So it's coming in from up here, and when we get to negative 5, it's even, so it's gonna bounce back up, and it's going to cross here, and it's going to cross here. That is what our graph's going to look like. Okay, what are we supposed to answer? Okay, maybe we'll answer a few just to make sure we know how to answer it. This one on the worksheet, it says, let's answer this. Where is, I'll do different colors for this. Let's just, where is QR of x less than or equal to 0? All right. Then let's answer this next one. Where is it just less than 0? Then let's answer this. Where is greater than or equal to 0? And then let's answer this last one. Where is it greater than 0? This is everything I could ask you. Okay, where is this guy greater than 0? Okay, here we go. Where is he negative? For what x values is this guy negative or equal to 0? All right. Here, it's never allowed to equal 0, so don't include this point. Here it equals 0. Here it's negative. Here it equals 0. So the answer for the black question right here is from negative 3/4 to 4 with brackets. Okay. For the blue question, where is it just negative? Okay, it's positive, it equals 0. Here it's just negative. This would just simply change to negative parentheses, negative 3/4 to 4 parentheses. Okay. For the red question, where is this guy positive or equal to 0? It's positive, it's undefined here. Don't include that point. It's positive and equal to 0 here. It's equal to 0 here and positive. So for the red question, well, let me just change it to red. This is what I can include for the red. This is the red. So this is what it was. Here, here, include this point, and up. So where is it positive or equal to 0? It's going to be from negative infinity to negative 5. Don't include negative 5, undefined. Union it with negative 5 to negative 3/4. Close. Union this with bracket, that's a bracket, 4 to infinity. What if they only want to know where it's positive but not equal to 0? Then this would be like this. Negative infinity to negative 5. Negative 5 to negative 3/4. Union with 4 to infinity. Okay, let's do two more really quick. M of x is this. And I won't go through all 4 scenarios this time, just so that it's not a super long video. Number 3 is this one. M of x. M of x is negative x squared times x minus 2 all over x plus 3 squared. Equivalent polynomial form looks like negative x squared, x minus 2, x plus 3 squared. The zeros are x is 0 with the multiplicity of 2, it will bounce. X is 2 with the multiplicity of 1, it will cross. X is negative 3 with the multiplicity of 2, it will bounce. The end behavior, negative, leading coefficient down to the right. The degree is 2 plus 2 plus 1, which is 5, which is odd, which means the left behavior will switch up. So, right here. Which ones came from the denominator? Negative 3. This has got to be open circle. These can be closed. So over here at negative 3, open. At 0, closed. At 2, closed. So the sketch will be, it starts up to the left. It gets to negative 3. It's got a multiplicity of 2. It's going to bounce. So it's here. It's going to bounce. When it gets to 0, it's also got a multiplicity of 2, so it's going to bounce, and then it's going to cross right here at 2. All right, so let me just make sure I haven't messed up. 0, multiplicity of 2, bounce. Negative 3, multiplicity of 2, bounce. 2, multiplicity of 1, cross. Open circle, close, closed, end behavior, negative, odd, up. Okay, I like it. So now, what we're supposed to answer here is, where is this greater than 0? Where is this just positive? Okay, just positive is don't include where it equals 0, just positive. So that's going to be from here, don't include this, here, don't include this, here. So where is it just greater than 0? It's going to be from negative infinity to negative 3, from negative 3 to 0, from 0 to 2. That is where it's just positive. What if, I have to do the what if. What if it's greater than or equal to 0? What about this one? Then, in that case, we could include where it equals 0, except for we can never include that point because it's undefined there. So that would be negative infinity to negative 3, union with negative 3, positive equals 0, all the way to 2. That's what that one would look like with the bracket. Okay, last one. This is R of x. Our R of x goes like this. Is equal to negative x squared over x minus 4 times x plus 2. Our equivalent would be negative x squared times x minus 4 times x plus 2. X is 0, multiplicity of 2 would bounce. This came from the numerator, it can be closed circle. X is 4, multiplicity of 1, it will cross. This came from the denominator, open circle. X is negative 2, multiplicity of 1. This will cross. This came from the denominator, open circle. In behavior, it is negative, leading coefficient down right. The degree is 2 plus 1 plus 1, which is 4, which is even. The left behavior will follow the right behavior. Here's our sketch. I'm over here at negative 2. I'm at 0. And I'm at 4. except for who has to be open? 4 and negative 2. All right, this is down to the left, so it's coming up from down. When it gets to negative 2, it's going to cross. So we're going to go through. And when I get to 0, it's going to bounce. When I get to 4, it's going to cross. All right. That's what our sketch looks like. And this is a closed circle. Okay. All right, so what do we have to answer for this one? Where is this guy negative? We only want the negatives. Okay. So don't include where it equals 0 and don't include where it's positive. So it is negative from negative infinity, from x is negative infinity to negative 2. Union with, don't include positive, don't include where it equals 0, 4 to infinity. So again, this is the LACING method, and this is not at all how you would graph a rational function. This is simply a tool we're using to answer an inequality, a rational inequality. All right.